Good evening, everyone. So we are starting that chapter, alternating current. Now this is the third lecture, and today 8, 8/9/2021. So now in this, from the previous lecture, we know what is reactance, we know what is inductive reactance, we know what is capacitive reactance, we know what is impedance, we know what is AC triangle, and that AC triangle is the most important part. Okay, if this is my pure resistance, this is my reactance, this one is my impedance Z, and Z is equals to R square plus X square, and X is equals to XL minus XC. XL is omega L, XC is 1 by omega C, and this angle is called phi. This is called the AC triangle. Tan phi equals to perpendicular by base. That is XL minus XC by R. Now, one by one, we see all the circuit today. We are not start in the previous class. We just in the previous class show you how you calculate this, and from today we start this. So my first heading is LR circuit. LR circuit. CIR CUIT circuit. LR circuit. In this LR circuit, what exactly happened? What exactly happened? Suppose we have an inductor and a resistor connected in series with the input EMF plus minus E equals to EM sine omega t. So this is my current outgoing, this is my current incoming. So my main aim on the basis my input signal, I have to draw or I have to write my output signal, which is current. So before we start, obviously, what is my XC? 0. Why? Because no XC is there. And what is my XL? I already know it, omega L. So what is my X? That is XL minus XC. So I can say omega L, yeah, XL. R is also there. So I can easily calculate the value of Z. I can easily calculate the value of Z, that is R square plus X square, and my X is XL and R square, and XL is how much? Omega L square. Once I get the value of Z, see, I can easily find out IM. Why? I already have EM, and Z just now I calculate here. So I get the value of EM by Z, I get the value of IM. Now I have to find out my phase angle. So how can I find out the phase angle? Very simple. Tan inverse X by R. Now this is equals to tan inverse X. X is how much here? Omega L by R. By putting this value, I can get the value of this. Now, that whether the given value, given equation is which type, for that I have to draw the phasor diagram. What is my phasor diagram? I think all of you remember, if this is my circuit phasor diagram, at any instant, I am drawing this red one as a E equals to Em sine omega t. And I think all of you remember, in case of pure inductor, inductive current is lead by 90 degrees. Yes or no? Everyone, you remember last to last class?
Yes, sir.
Yes, sir.
These three very important key factor. So this is my current due to inductor, which is 90 degree lead with respect to my input signal, and this is my at any instant angle. And in case of pure resistor, the resistive current is on the direction of the input EMF. So I can see clearly IL and IR, they are 90 degree to each other. So resultant of these two is my I, which is with respect to the previous one, this angle. How you get this angle? We already find out this angle. Now tell me, with respect to EMF, that red one, that black one, this one, lead by this angle or lag by this angle? Everyone, lead by this angle or lag by this angle? With respect to this red one, this I, lead or lag? What you realize? Anyone, please respond.
Sir, lead.
Obviously, read. We can see it. Reference से आगे रहेगा तो lead, reference से पीछे रहेगा तो lag. So what I can write my final equation Im. How I get it from here? Sine as it is, sine omega t, that part as it is. Now it will be lead plus phi. How you get this phi from here? Understand?
Yes, sir. So,
Everyone got it?
Yes, sir.
Okay. Now on that basis, I can try. Or now the question is that which type of question they ask you? They ask you very simple type of question. They ask you a very simple type of question, like a question: when an inductor L and a resistor R in series are connected across a 12 volt 50 hertz supply, a current of half ampere flows in the circuit. The current differ in phase with the applied voltage is pi by 3. Calculate the value of R. That question I already show you in the previous class. So this voltage and this current. Anyone please tell me these values are in RMS value or peak value?
sir, RMS value.
Always RMS value. So we can write V, that is the VRMS, I, that is the IRMS, and always we use Z. Z is the overall resistance. So what is my Z? I think I don't have any problem to say what is the value of Z. That is 24 ohm. Yes or no? Yes or no? And
Yes,
it is a clearly L and R circuit. So my XC is 0. So X is XL minus XC is XL. And what is the Z? Z is R square plus X square, and X is XL. So R square plus XL square. Yes. Now see here, you get the value of tan phi, that is X by R, and here X is 0. So X is XL by R, which is how much? Tan pi by 3. What do you mean by pi by 3? 60 degree. That means root 3. That means, what do you mean by XL or X? That is root 3R. So I can easily put it here, 24, that is R square, I don't know. And X square or XL square, you can write anything, that is root 3R whole square. After solving this, you have R square plus 3R square, that is 2R. So it is very clear, R equals to 12 ohm. Yes or no? Understand?
Yes, sir.
I just show you the strategy how you solve this type of question. Rest of any type of question you can solve it. So now we try to first solve all the theoretical things. Okay. Now the next one, that is CR circuit. CR circuit. I think all of you understand. You have a capacitor, you have a resistor, and you want to connect it with the input signal. So E is equals to EL sin omega t. This is I. This one is I. So now in this case, I can say XL is 0 and XC 1 by omega C. देखो बुक में क्या क्या है? बुक में जो first one you write, IM equals to E equals to I equals to IM sin omega t plus phi. They think or they suppose it as a reference, and on that basis they say X is XL minus XC, that is 0 minus XC, that is minus XC, that is 1 by omega C, and sometimes they give the statement reactance is negative. Whatever reactance is negative or not, it doesn't matter, but my impedance, which is always R square plus X square, so I can write R square plus 1 by, if you write 1 by omega C also, this is R square plus 1 by omega C whole square, it will be always positive value. Yes or no?
Yes, sir.
So you can find out phi, don't find out plus or minus, simple X by R. So tan inverse X is XC by R, or you get the value minus, or you get the value minus one with respect to the previous one, it will be reversed, but we don't require that. Also we can write directly tan inverse XC is 1 by omega C by R, that is tan inverse 1 by omega C R. Clear everyone? So from that you get the value, at least you get the angle. What about the IM? Same process, you already have EM, you can find out Z. Once you find out both of them, you can easily calculate. You can easily calculate this value. So now phasor diagram. In phasor diagram, E equals to EM sin omega t, theta, which is omega t. Now tell me, in case of pure capacitor, capacitive current lead or lag? Hello? Remember last capacitive current lag by 90 degree, remember? Yes or no? याद है?
Yes, sir.
हाँ यार. Phi phase angle. So the final current is lag or lead? Anyone please tell me with respect to the EMF?
Sir,
Sir,
lag.
lag.
Lag, very good. So I can write Im, which I can get from here, sine omega t minus phi. Okay, or you can write here, you put the value minus, in this phi you get the value minus, so you can write directly with respect to the previous one. Previous one is plus, this one is minus. So we don't need this, we can draw it by the graphical also. That is better by using the, by drawing the phasor diagram. Now again I want to give you one numerical from that part. So the question question is that in the circuit shown in the figure, the potential difference across, अच्छा, this is also inductor and resistor. नहीं, ये कैपेसिटर का क्वेश्चन चाहिए मुझे. कैपेसिटर का क्वेश्चन नहीं है यहाँ पे. Wait, just give me one. An alternating current of 1.5 milliampere, 1.5 milliampere RMS, ये बोल भी दिया है RMS, नहीं भी बोलता तो भी होता. An angular frequency 100 radian per second flows through a 10 kilo ohm resistor and a 0.5 microfarad capacitor in series. Calculate the value of RMS voltage across the capacitor. Calculate the RMS voltage. Mane you need VRMS. This is the first thing, and also calculate the impedance of the circuit. So my first thing is, first of all, if you want to calculate the impedance first, I can directly write R square plus 1 by omega c whole square, yes or no? So R is my 10 to the power 4 whole square plus 1 by omega, that is 100, because it is angular given, that's why it will be easy a little bit. Pi omega c is 1 by 2 into 10 to the power minus 6. So what you have, whole square, that is 10 to the power 4 whole square plus ये कितना जाएगा, 10 to the power 6, माने 2 into 10 to the power 6 by 10 to the power 2 whole square, that is 10 to the power 4 whole square plus 4 into 10 to the power 4 whole square. So that means you can take 10 to the power 4 common, and here you have root 5. Yes or no?
Yes, sir.
We can write root 5 10 to the power 4 ohm is the Z. So I get the value of Z. Calculate the value of impedance. Yes or no?
Yes, sir.
Now the next thing is you have to find out the VRMS. See, as IRMS is already given, into Z is your VRMS. That is 1.5 10 to the power minus 3 into root 5 into 10 to the power 4. So what we can write, 1.5 into 5 into 10. That means 15 root 5 volt. Yes or no? ओ अच्छा, यहाँ पे एक और बात है, इसमें ये नहीं पूछा है कैलकुलेट द वैल्यू ऑफ आरएमएस वोल्टेज अक्रॉस द कैपेसिटर बोला है, टोटल वोल्टेज नहीं बोला है. इज इट क्लियर एवरीवन? हेलो,
Yes, sir.
क्वेश्चन में ये नहीं बोला है कि RMS वोल्टेज बोला है, RMS वोल्टेज across the capacitor. वही मैं देख रहा था आंसर क्यों नहीं मिल रहा था. If they ask you the RMS voltage, that is your answer, but they ask you RMS voltage across the capacitor. So VRMS for capacitor, so IRMS into XC, yes or no? And from here I have the value of XC. My XC is, I can easily see it, 4 into 10 to the power 4 ohm, yes or no? Yes or no?
Yes, sir.
So 1.5 10 to the power minus 3 into 4 into 10 to the power 4. That is 1.5 into 4 into 10. 15 15 30 30 60. यहाँ पे ओह एक और मैंने गलती कर दिया, जस्ट 1 मिनट, सॉरी. यहाँ पे जो है ना 1 बाई ये 2 है, 2 का स्क्वायर इज 4, तो इसलिए 5 आया है. यहाँ पे ये 2 है, सॉरी ये 2 है तो यहाँ पे 2 होगा, तो ये अगर 2 तो 30 वोल्ट. क्लियर एवरीवन नाउ? आई थिंक नाउ इट्स ओके, तो यहाँ पे 5 लिखा था ना. क्लियर एवरीवन?
Yes, sir.
Yes, sir.
एक और देखो यहाँ पे क्वेश्चन है, मैंने टिक मार के रखा है, मतलब अच्छा क्वेश्चन ही होगा. I just want to explain it, just 1 minute. देख तो लेते हैं कुछ क्वेश्चन में. एक्चुअली ना सो मच कैलकुलेशन इज देयर. फाइंड द इम्पीडेंस and find the impedance of the circuit shown in the figure for number 1 direct current मतलब DC. Number 2 alternating current for AC. Of frequency given है 10 by pi किलोहर्ट्ज. ठीक है, तो तुम्हें क्वेश्चन में समझ में आया होगा. फाइंड द इम्पीडेंस फॉर डीसी, फाइंड द इम्पीडेंस फॉर एसी. व्हेन इट इज एसी द फ्रीक्वेंसी इज दिस मच. क्लियर एवरीवन? इज इट ओके?
Yes, sir.
एनीवन टेल मी फॉर डीसी व्हाट इज द वैल्यू ऑफ ओमेगा? लास्ट डे ही किया था कि why capacitor does not allow DC current but it can allow AC current. क्या बोला था DC का वैल्यू? फॉर DC तुम लोग भूल बहुत जल्दी जाते हो. फॉर DC ओमेगा इज 0, नो फ्रीक्वेंसी फॉर DC. इट्स अ स्ट्रेट माने नो वाइब्रेशन. वाइब्रेशन नहीं है तो फ्रीक्वेंसी कहाँ से होगा, ऑसिलेशन कहाँ से होगा? वाइब्रेशन के लिए ऐसा होना पड़ेगा ना, नो वाइब्रेशन. सो फॉर DC ओमेगा इज 0. So if my omega is 0, if my, अच्छा यहाँ पे एक सर्किट भी दिया हुआ है, I forget to draw this circuit. ऐसे करके ये है 20 ओम और ये है 2 माइक्रोफैराड कैपेसिटर, और इस सर्किट का बोला है. ठीक है, व्हाट इज द इम्पीडेंस? इसका Z कितना है? कब? नंबर 1 फॉर DC ओमेगा 0. So when the omega is 0, XC 1 by omega C, something by 0 is infinity, yes or no? So whatever be my Z, R square, whatever be the value, plus XC square, so R square plus infinity square is infinity, yes or no?
Yes, sir.
So without calculation I can say for omega 0, XC is infinity, so my X is infinity, so my Z is also infinity. Clear? Okay, is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Now the second part for AC. So as it is AC, my frequency is given 10 by pi kilohertz. So XC is how much? I have to find out this one. 1 by omega c, that is 1 by 2 pi frequency c. So 2 pi, देखो frequency examiner अच्छा है, pi को cancel करने का मौका दिया है, 10 to the power 3, and c is 2 micro, 10 to the power minus 6. सबसे पहले इसको काटो -3, फिर इसको ऊपर ले जाओ 10 to the power 3. अब बचा हुआ कौन बचा, देखो तो ये बचा एक 10, ये बचा एक 2, ये बचा एक 2 ना, तो 40 आई थिंक. यस और नो? कितना आया? ये आया 100/4 माने 25. यस और नो?
Yes, sir.
So what about the z? 20 का square plus 25 का square. I don't know what is the value. You can calculate and tell me. If everything is right here, you can check it once before you confirm it. ताई हवे. So 200, 400 plus 625, that is 1025. Calculate this and tell me the value. Okay. यहाँ पे तो लिखा है 32. I don't know it's a right value or wrong value. यहाँ पे they give you exactly 32. So you can try this and tell me the answer. Okay. Understand? Is it okay?
Yes, sir.
Okay. Next. Next topic is LC circuit. LC circuit. So what happened in LC circuit? You have an inductor and you have a capacitor, L and C, connected with the input signal. E equals to EM sin omega t. So first of all, my R is 0 and XL is omega L, XC is 1 by omega C. So X is XL minus XC, omega L minus 1 by omega C. So Z is R square plus X square, that is 0 plus X square, matlab X. Mane my Z is X. Yes or no?
Yes, sir.
If it is possible, positive, then also negative ka square, positive ka square root positive, negative ka square root positive. Once you get the value of Z, I can easily find out IM, that is EM by Z, which is equals to X, I can say. So I don't have any problem with this. Now, when we draw the phasor diagram, then we know this one is my E equals to EM sin omega t. I don't have any doubt with this. And I also know if we have this one, IL. Yes or no? Hello, am I audible?
Yes,
Hello?
sir.
So, अरे नेटवर्केर आजकल जे की হচ্ছে না, এত ভালো নেওয়া ইয়ে নেওয়া 5G নেটওয়ার্ক নেওয়া, তারপরে সালা ভারতবর্ষটাই হচ্ছে করাপশনের দেশ। হ্যাঁ,
5G কোথায় পেলে?
ওটা তো রিলায়েন্স জিও তো 5G বলে, এটা 4G না 5G অপটিক্যাল ফাইবার?
4G স্যার।
এটা 4G না, এটা 2G। Okay, so you understand this one? हाँ,
हम तो सोए 3 बजे सर।
तुम्हारा सोना और उसका कारण 5 बजे
स्कूल
सोना,
যাচ্ছে স্যার।
फिर सुबह 7 बजे उठ के स्कूल जाना मामूली बात है।
हाँ सर वो तो है।
तुम लोग तो 12-1 बजे सो के भी उठता है ना, सो के कितना
हाँ
बजे
सर
उठा
6
है?
बजे उठता है सर।
3 बजे सो के 6 बजे उठ गया।
हाँ सर।
तुम लोग अभी यंग है ना, तुम्हारा अभी उम्र है 18 साल, मेरा उम्र है 40 साल। सोचो, ए हो गया? हेलो, एम आई ऑडिबल?
यस सर।
तो अब देखो, इसमें मैंने बोला था इफ एक्सेल ग्रेटर देन एक्सी, सो VL इज दिस साइड, याद है? और इफ एक्सी ग्रेटर देन एक्सेल, तो दिस साइड, है ना? याद करो। सो इफ द एक्सेल इज ग्रेटर देन एक्सी, सो मेरा जो नेट करंट होगा ये किधर जाएगा? कि इफ एक्सेल इज ग्रेटर देन एक्सी, तो मेरा इधर जाएगा नेट IX, and if my XC is greater than XL, so मेरा नेट इधर जाएगा। समझ में आया? So both are not at a time not possible, either this one or this one. So it could be plus 90 or minus 90, we don't know, because we are not in a condition ki we can comment it. We can comment it that ki it will be plus 90 or minus 90 after we see the data. Like if we get XL 60 ohm and we get XC 30 ohm, so we can say XL greater than XC, so phase angle is positive, that means plus 90. If we get XL is 32 ohm and XC is 50 ohm, so XC is greater than XL, so what happened? XC greater than XL, that means minus 90. So we can't comment it, but we can write in that manner. IM is omega t plus or minus 90 degree, depend on which one is greater. Yes, understand?
Yes, sir.
But we can't comment it because until we don't know who is greater, we can't give any comment. Now अब देखो इसका क्या है, इसका एक बड़ा सुंदर सा चीज है. From there it will be a little bit different. कि if we see the XL omega L, if we see the XC 1 by omega C, so X, that is XL minus XC, R तो 0 है, तो Z is X, okay, and I maximum, that is E maximum by Z, which is X. Now once my omega is 0, this one is 0, this one is infinity, this one is infinity, this one is infinity, this one is 0. Once my omega is infinity, this one is infinity, this one is 0. The difference is again infinity. Z is again infinity because Z is root of mod of this, always positive value, again 0. Is it clear, everyone? Is it okay, everyone?
Yes, sir.
So are you realize what I want to say? What I want to say? Are you realize what I want to say? That means what we realize initially my XL is 0, XC is infinity, and as my omega is infinity, XL is infinity, XC is 0. मतलब मेरा जब ओमेगा 0 था ये ऐसा था, जैसे जैसे मेरा ओमेगा इंक्रीज कर रहा है it will be like this, and when my omega is infinity it will be like this. Yes or no? Yes or no?
Yes, sir.
So initially when my omega is 0, XL is 0, XC is infinity, and when my XL is increasing, omega is increasing, XL increasing, XC decreasing, एक time they equal, and then reverse thing happen. So that I just want to show you कि so there is a chance कि sometime both are equal. Huh? So when when XL is equals to XC. एक समय ऐसा आएगा कि they are equal. When they are equal, ठीक है, that frequency is called when they are equal at that particular frequency or angular frequency is called resonating frequency or angular frequency. समझ में आया? कब का? When they are equal. So it is a special frequency. Omega L is 1 by omega C. It is a special frequency. So omega RL, omega RC, it is a special frequency. So omega R square is 1 by LC. That means omega R is 1 by root under LC. Is it clear? Is it clear? Is it clear, everyone?
Yes, sir.
So
That is equals to 2 pi resonating frequency. So my my resonating frequency is 1 by 2 pi into 1 by root under LC. Very, very important. Why I am representing it by the symbol R? R for resonating. Clear? Special frequency. Yes? Yes or no?
Yes, sir.
And one more very important part. Important note. If XL is XC, I can multiply it with the current also. And VL is VC. That means I can see the reverse thing also. If VL is equals to VC, that means XL equals to XC. That means resonating frequency. Yes or no? Resonating. Understand? Is it clear?
Yes, sir.
So now at resonating frequency, what about my X? Because XL and XC are equal. So XL minus XC equals to 0 as XL equals to XC. Yes or no? Yes or no?
yes, sir.
Yes, sir.
So if they are equal and equals to 0, so what is my Z? Z is X, that is also 0. If my Z is 0, what is my current? IM by Z, which is X, which is 0. That means infinity, yes or no?
Yes, sir.
So if I want to draw current versus, if I want to draw number 1, this one is my Z, this one is my frequency, omega equals to omega R, resonating frequency. And so when my omega is 0, you just remember Z is my 0 infinity. And when omega equals to at resonating frequency, my Z is 0. So how it look like? It looked like it is coming from a very large value and decrease to 0, and then again start like infinity. Why? Because at infinity, Z is infinity. Yes or no? And similarly for current, exactly the opposite thing happen. If you want to draw a current versus angular frequency omega equals to omega R. This is omega. So when the omega is 0, my current is 0. And at omega equals to omega RC, my current is infinity. And then again it will be decrease. So it will be increase like this and become infinity, fall from here and become 0. You just compare it with the previous one just now. ये देखो. When my omega is 0, z is infinity, I is 0. When my omega is 0, z is infinity, I is 0. When my omega is infinity, z is infinity, I is 0. See, infinity 0. And at resonating frequency, my I is infinity, z is 0. है ना? Understand? Yes.
Yes, sir.
So this is my current frequency and impedance frequency graph. So later on, so that means we now see LR circuit, CR circuit, LC circuit, and the last one is remain, which is the most important one. And why this is the most important one, I say you it later on, but first see it LCR. So in this LCR, you have an inductor, you have a capacitor, as well as you have a resistor. LCR. Okay. So if you connected it with this one, plus minus E equals to EM sine omega t. This is my I. This one is my I. So first of all, we know all the value XL, omega L, XC, 1 by omega C X, XL minus XC, omega L 1 by omega C Z, that is root under R square plus X. I M E M by Z, we have this value. Anyone, any doubt? If you want to time pass, I can time pass. Omega L minus 1 by omega C whole square. I can write in that way. I can write it again. Omega M EM R square plus omega L minus 1 by omega C. But meaning to एक ही है. Z निकालो if you want to able the value of Lagrange हाथे ना. If you're able to find out the value of Z, you can find out this value. Now after that, you can able to find out phi tan inverse X by R. Once you get the value of X by R, yes, you can get a particular value. So again, if we draw a phasor diagram, what we realize, I think all of you remember, first I'm representing by the red ink E equals to EM sine omega t. This is theta omega t. Now I'm representing the current due to inductor and capacitor by the blue ink. So I can say this is my IL, this is my IC, and I am representing the pure resistance wala current by the black ink. Now suppose I am here giving, I don't know which one is getter, so any one can be, so I can write Ix in this side or Ix is this side by the green ink, where if the Ix is this side, that means IXL is greater than XC, and if Ix is in this side, that means XL is less than XC, mane XC is greater. So from that what we can say, my resultant of these two, either this one I final or that is the IZ, hope you remember, my this one. So it could be plus phi or minus phi, again depend on the situation. Situation means what is given, XL greater than XC or XC greater than XL. If XL is greater than XC, then plus 1. If XC is greater than XL, then -1. So I can write my EMF, sorry, the equation of current, that is IM, I can find out from here, sine omega t plus or minus phi, depend on XL greater than XC or XC greater than XL. Now, same way, just like the previous one I show you. Up to this, is it okay, everyone? Hello?
Yes, sir.
And I think all of you realize, why I am giving you a very much effort on that graph now. You understand? कि मैंने बार lead lag Z निकालो, phi निकालो, क्यों बोल रहा था? I think now you understand. और ये हो जाने के बाद हम लोग from the next class इसका mainly numerical करेंगे और भी कुछ छोटा चीज है वो करेंगे, फिर we move on to the transformer. बहुत ही अच्छा चैप्टर है और थोड़ा बड़ा भी है, बहुत कुछ है इसमें. So now I think same way we can write now XL omega L XC 1 by omega C X XL minus XC. I can write Z, that is R square plus X square. I can write IM, that is EM by Z. Now when my omega is 0, this one is 0, this one is infinity, this one is infinity, this one is infinity, this one is 0. When my omega is infinity, this one is infinity, 0, infinity, infinity, 0. So what do you mean by that? Same thing. When the omega is 0, XL is 0 and XC is infinity. When omega is infinity, just the reverse thing happen. So there is a time when they are equal. So that time is called the at resonating frequency. Resonating frequency. I can write now XL equals to XC. I already show you this. So omega RL 1 by omega RC. So omega R square 1 by LC. That means omega R is 1 by root under LC, which is equals to 2 pi frequency. So frequency is 1 by 2 pi 1 by root under LC. So these are the two equations you have. That is the first very important thing. And the most important one is why this one I'm saying LCR circuit is the most important one. How you can understand कि at resonating as XL is equals to XC. Okay, my X is XL minus XC is 0, but my Z is R square plus X square is not 0, that is R, right? So as my Z is not 0 R, my IM is EM by Z, which is R, is the maximum value, not infinity. So you understand there is a huge difference between current is infinity and current is infinity. Hello. So this is my resonating frequency, and you realize one thing, that here in resonating frequency my current is not infinity. देखो infinity होने का मतलब क्या है? Infinity मतलब heating effect huge, फट से आग लग जाएगा. लेकिन maximum value but controllable value माने by increasing the value of R, we can control the frequency, means we can control the current, which is very important. So if I want to draw current versus angular frequency graph with the previous one, what is the basic difference? Omega equals to the R. If you see this, when my omega is 0, my current is 0, and when my omega is infinity, my current is 0. But omega equals to omega R resonating, it is not infinity, it is a maximum value. So I get a very good what you can say? हमें एक अच्छा सा respected value मिलेगा which we can control on the basis of मेरा input resistance क्या है. So and in this at resonating frequency it is behave like a pure resistor. So this is my EMF E maximum value by R. Yes or no? Current. Yes or no? And that's why this current is a very controllable current because it's not infinity. And on that basis, if you want to calculate the Z versus this one, how it look like omega equals to omega R. This is Z, this is omega. So it look like this. Z is equals to R. Clear? Yeah. Everyone, is it okay? Everyone, is it okay?
Yes, sir.
So that's it for today.